Alright kids, one more section in chapter 7. This time we're going to deal with systems of linear inequalities and linear programming. Now all the problems in the homework are going to be linear programming problems, but I do want to review with you how to graph the systems of inequalities. Okay. First, let's do a real basic one. They want us to draw the graph of y greater than or equal to 2x plus 3. So your y-intercept is 3, your slope is 2. So up 2 over 1, up 2 over 1. Now, it's a solid line because it's or equal to. That's about as straight of a line as I can draw, kids. Okay, which side do you shade? Okay, plug in 0, 0. Now, I understand you can do this in your calculator, so just bear with me. So when I plug in 0, 0, is 0 greater than or equal to 3? No, it is not. So we do not shade the side of 0, 0. We shade away from it. Okay, you guys did that in Algebra 1 back in like 4th grade or something, whenever you guys took it. Okay, when you have a system of inequalities like this, all right, you can graph this on your calculator. Okay, the only thing that I will ask of you is that you do graph. I will provide graphs, and you can graph these on the graph paper. I know, that you guys want to do it on the calculator, and that's fine. But y greater than x squared is easy. So here are the points for y equals x squared. Now, it's greater than, but it's not or equal to. It's hard to do dotted on here. Okay. Okay, so that's a dotted parabola. A terrible dotted parabola, but a parabola nonetheless. Okay, let's change colors here. Alright, so here, okay, you're going to have to solve for y. Whether you use the calculator or not, you're going to have to solve for y. So 3y less than negative 2x plus 4. Divide everything by 3. So y is less than negative 2/3 x plus 4/3. So your y-intercept is at 4/3, which is almost, or just a little bit past 1. Now we're going to go down 2 to the right 3. Okay. We can do the same thing. We can go up 1 to the left 3. And that'll put us, that'll put us right about there. Okay, so actually I got to go up 2. That would help if I knew how to count. So up 1, 2, to the right 3. That kind of puts us in that area. So here is my dotted line. Now, at this point, guys, it doesn't matter to me. You can obviously put it in your calculator and find out that the common region is right in there. Okay? Now, quick reminder. When we talk about, in the calculator, putting in greater than or less than, okay, here's the key. So to the left of your y equals, okay, the upper right-hand shaded portion, that's greater than. The lower left shaded is less than. Okay, so this is for your calculator. All right, make sure that you put the right thing in. Okay. All right, now we get into bigger systems. 4 inequalities. Now, if you take a look at these, x is greater than 0 and y is greater than or equal to 0. Basically what this means is this is restricting our boundary to the first quadrant. You're not actually going to shade for those two lines. You just know that x and y both have to be at least 0. So, y, get out of there. Y is less than or equal to negative 2x plus 10. So the y-intercept is 10. Down 2 to the right 1, down 2 to the right 1, down 2 to the right. I'm just going to keep going. until I get to the x-axis. Now, it's or equal to, so it is a solid line. Wow, I can't believe how straight I'm drawing these. Okay? All right? Now it's less than. Now again, you're going to put it in your calculator, so you don't have to worry about the shading. Do the shading at the end and use your calculator to determine where to shade. Okay? So, whoops. So here, we have 3y less than or equal to negative 2x plus 14. Divide everything by 3. So y is less than or equal to negative 2/3 plus 14/3. Okay, whoops, x. So 14/3, that's 4 2/3. So that's right about there. I should probably change colors. That'd be a good idea. Okay, so it's right about there. So then from there down 2 to the right 3. Down 2 to the right. Let's see, 1, 2, 3-ish. Okay. Now, again, I am going to want you to graph these on your paper. Okay? It's not enough to just do it in the calculator. You could do it in your calculator, but you have to reproduce that on here. And there's a reason why. And the next example is going to show you exactly why you need to do that. Okay? So when you graph it on your calculator, you're going to see this area right here. That is the common region. So that would be your answer. Okay? So it's just basically the overlapping of all the shaded areas. Okay. Now to the linear programming. It says find the maximum and minimum values of the objective function f equals 5x plus 8y subject to the constraints given by the system of inequalities. So again, 2 of them are the zeros. So that just means first quadrant. Now, if you notice the 2 inequalities on top, they're the exact same ones we had for the last problem. Right here. Now, here's what you need to do. You need to find the coordinates of all the vertices of that shape. So you've got to do your intersect function. You've got to do your zero function. Okay? So your 4 points here are 0, 0. Okay? 5, 0. 4, 2. And 0, and then 4.67, or 4 2/3. Okay? So I'm not going to graph it again on here. Here's the graph. But you need to find the coordinates of those 4 points, because those are the vertices of your region that is the common shaded area. Now what you're going to do is you're going to take each one of these points and you're going to plug it in to the objective function. So here, f, well now first of all, f is 0 here because 0 plus 0 is 0. Okay, plug 5 in for x, plug 0 in for y. So I get f equals 25. Plug in 4 for x and 2 for y. So 20 plus 16, f equals 36. Okay, last one. Bring it down here. Okay, 8 times 4 2/3. 8 times 14/3. Oh, do some math. 112 over 3, which is 37.3. Repeating. Okay? So your maximum is 37.3 at the point 0, 4 2/3. Your minimum is 0, and that occurs at 0, 0. Okay? So, linear programming is this problem, example 5, but with an objective function that you have to find the coordinates here of your vertex points and then plug each point into the objective function. The largest f value gives you the max, the smallest one gives you the min. Last one, which will actually table for right now. The video is at just a shade over 10 minutes, and that's exactly what I wanted to keep it at. Okay, we will go over this problem in class, but just so you know, this is the graph of what all these equations are going to wind up being. But like I said, we'll go over that in class. I want to keep this at 10 minutes. That's the basics of graphing the system of inequalities on the calculator and then putting that on your paper.